screen here. Okay, so welcome. Today I'm introducing Visual Clojure. Subheading here, modernizing office solutions on the CLR and Windows and beyond. Is kind of the sizzle. The steak is really to talk about the strategic reasons for using Clojure, for what we're doing with it, keeping in mind that the products and projects that we'll be talking about and sharing about will also be available for people to do whatever they imagine to do with it. Gonna kind of get moving here. Just there we go. So the Reader's Digest condensed version of that little bio for me is that I'm an experienced enterprise architect with a lot of passion for distributed systems and for programming languages, kind of a polyglot. The agenda for today, it's kind of loose because the discussion that I hope to have will be a little bit more flowing and desultory. I'm going to do a quick recap and a quick tour of the previous talk I did, I think back in March, for the London Clojurians, covering Accelerate for Microsoft 365, the standard edition. That'll get into a discussion about Scheme, which was the first Lisp that we introduced to this solution, and why it makes sense, particularly in the Excel context, as an alternative perhaps to lambda functions that were recently added to the 365 version and to traditional VBA development. That will lead into a discussion about why the professional edition is going to introduce Clojure as well. It's not really any big lack in Scheme so much as it's an entirely different aspect or use case for what we're trying to do, and it has very unique strengths that recommend it for that use. By the by, the theme will generally be Clojure as kind of the ideal language of interoperability. I know that developers have in mind what interop means. It means interop with the runtime or interop at some sort of code level. But the interop I'm talking about is a little bit broader of a concept, having to do with data interoperability between systems. Think in terms of healthcare. Wouldn't you like it if when you went to see one doctor and you updated your stuff, you go to another doctor and they magically just have the information already? That level of that concept of interop in the industry has been getting a lot of attention without going very far into the operability side of things until recently. And that's the subject matter that got me on this path to create specifically this and the upcoming products that we'll be talking about. And there is an open source angle as well, which I'll introduce what our plan is there. Ask questions anytime. Live interaction is welcome. This is going to be, I want this to be kind of more of a discussion or kind of a topic-driven presentation. There will be opportunities, I hope, in the future to come back and do a full-on proper demo of the concepts in action, which we can talk about. Maybe that's a reclosure thing we can do, or maybe it's another one of these closer to the beginning of the year. In any case, I have some ideas about some killer apps and would like to take suggestions from people who are interested. Okay, so let's get to the quick tour kind of recap here. I introduced Accelerate add-in to Office back in March. Like any add-in, you have the option to add your own tabs, and so we have an Accelerate tab with a lambda button that allows you to insert scheme code for different use cases. There's raw lambda, which is just a lambda expression that computes based on however many parameters you specify and then call into it through the little function that we have that interoperates right with all the other functions in Excel. There's a define function that lets you create a named lambda that you can then call from other lambdas or directly as defined regions within Excel, just like you can do with let and lambda in the proper Excel product itself. You can apply a lambda to a region, 2D set of cells, and we have helpers to allow you to choose whether you want to do that by row or by column. And then there's evaluate, which is, it's not really eval in the sense you think eval in Lisp. It's more like evaluate a named lambda with the following parameters, or you can also create an inline one, just like the normal lambda function. So there's 4 different ways to get to bring Lisp into the spreadsheet, and it's quite interesting. We added to the UI of Excel, a lambda editor, and a proper REPL. And as we integrate Clojure into this, these will also work with Clojure right in the spreadsheet. So the picture here you see in the middle of the lambda editor, that pops out and is visible whenever you are on a cell that uses one of our functions, one of those 4 functions I described. The REPL, you can toggle in and out of view, and that gives you sort of a normal REPL-based experience to play with code. In this particular example, you can see I was including the mini Cameron library, which is kind of equivalent, the scheme equivalent to core.logic. And you can interact with it and kind of see the results right there in the REPL. And then you can kind of cut and paste the lambda portion of the call right into the lambda editor, give it a name, and then call it inside the spreadsheet. So you can see there, that's what's happening here. So all of that we walked through in the last presentation we did in March. And we also exposed command line REPL and external script execution. So this really kind of opens up the model a bit. You're no longer stuck within Excel. You can write proper scripts. You can run tests. You can REPL kind of interactively with your favorite editor. I happen at the present moment to be back in my Emacs mode, so I've been using Emacs. But Visual Studio Code and Atom and Vim, NVim, they all have great integrations with Scheme and with Clojure. The challenge with those on Windows, obviously, with the ClojureCLR is that the tooling's not quite, it doesn't really interact with ClojureCLR yet. So that's part of the thing, one of the things I'm working on. With David Miller, actually, the guy who maintains ClojureCLR. Great guy. Really enjoy working with him. So the gist here is, and you can just take a quick look at the code there. It's quite high level stuff. We've put a lot of effort into making the experience of someone new to Lisp sort of really value added. There's not too many places where you can define a SQLite function in like 3 lines of code. So I think that's kind of cool. And the same lambdas that are being used there can be used in a spreadsheet. I think that kind of breaks out of that whole model of what a function is. All right, so quick to wrap up the tour. We're bringing a proper REPL-driven development into Excel and to the rest of the Office suite. We have external command line REPLing and scripting for kind of reach outside of the Office suite when you need to interact with other systems or anything else you can imagine to do. We provide a lot of libraries that are quite popular in .NET out of the box for things like logging, CSV manipulation, data access to SQLite. There's a NoSQL embedded database called LightDB that's also included. Just a lot of things that we have found very, very powerful and useful in this context are already out of the box present, and you can start writing code against them immediately. There's a bit more information about the product usage, at least as of August when it was published, and that is August-July timeframe. That was called the Excellent Schemer in Code Magazine. And next week I'll be doing a webinar with Code Magazine that is more of an introduction to Lisps and why we're bringing them into Office for more traditional .NET developers. We have a 30-day free trial on our website, which you're free to check out as well. Okay, so why, I gotta move this thing again. There we go. Why Scheme in Excel? I got to start with that because there is a thread of logic to moving into Clojure. There's a point of departure from one to the other that I found is quite clear, and it helps explain the difference between, say, standard and professional editions. Scheme is really an ideal entry-level Lisp, and it was kind of designed to be that, right? It's what they use it a lot in academia to teach concepts in programming like recursion and what is a computing paradigm and how do you build a language within a language. So all the properties that make it good from a pedagogic point of view makes it great as an introduction for developers in the Office world who, for the most part, know either the Excel expression language or VBA, Visual Basic for Applications. which is Microsoft sort of VB inside of Office for programmability. It is highly used. There's an entire cottage industry of VBA developers who have built, complicated solutions for small businesses and enterprises using it. But it's kind of stuck in the world of COM right now, and .NET is kind of moving out beyond COM. It's got COM Interop, but it's bigger than COM. So VBA doesn't really have reach into that world. It has a certain amount of FFI with C++ and C libraries, but it doesn't touch .NET. So the thing that I found with Scheme is it was a breeze, for the most part, kind of a breeze to use. And it's really easy to teach someone who doesn't really know programming. But it doesn't lack any power. It's got behind it a very powerful syntax extension mechanism, which I use gratuitously to create new constructs for interacting with data in the Office environment. One of the things that you can do, for example, in SQLite is create custom functions, and I'm going to kind of meditate a little bit more on this in a bit, but that's something that I wrote a syntax extension for, and I'll compare syntax extensions versus Clojure macros a little later in terms of what I've learned from using them. But here it was actually shockingly simple once I had the concept, and that's important because you have to take people on that journey as they learn their first exposure to Lisp. You have to take them on that aha journey to really understand the power of the paradigm. You can see also that there's like unit tests that read like natural language. For folks who are really new to Lisp, and particularly the VBA folks, I think this is a big win. So that's one of the reasons I started with that. If you think about what a good user interface to a new or non-developer is, it's all about abstracting away the complexity of things. And if you were to write this code in C#, which is perfectly doable, or even VB.NET, there's a lot more work and a lot more boilerplate. This is a pretty high touch syntax extension. As you can see, it goes define SQLite function. There's implicitly it's a 8.0 database connection. In this case, it's a SQLite connection to a connection that's in memory, defined previously. The function is given a name, ultimate answer. So this is how you would refer to it when you call it from within SQL. And I'm giving you sort of a Haskell-like declaration of what goes into it. So in this case, ultimate answer doesn't take any parameters and it returns an int 32. Times 2 takes 2 ints and returns, or takes 1 int and returns 1 int. And then, times 3 or add 3 takes 3 ints and returns an int. Now this is simplistic, but any type in all of .NET can be one of these types. So you can custom types written in a library you're using. Really, the sky's the limit. And so therefore, not only are we kind of breaking in .NET into Office, we're breaking it into things like SQLite and any other database adapters that permit custom functions. SQLite was the most accessible and is highly used, and it's a great alternative to storing data in Excel, which is a terrible idea, and B, storing it in Access, which gives you artificial limits in size and compatibility with the rest of the universe. So one of the things out of the box is SQLite, and I'm going for, I'll talk about this a little later. There's a whole topic on database transparency. I'm trying to get people away from the anti-patterns of like store all your data in Excel or use Access, all this other stuff going on. So anyway, my point is that you cannot do this in any normal scripting language. This is a very powerful and simple way to explain how to add functionality to SQLite that could potentially be reused even in the spreadsheet. And there's a quick glimpse at the actual syntax extension for that. The feature of syntax extensions in Scheme that kind of jumps out to me as kind of primary is the fact that it's got its own little DSL built in for doing syntax matching on patterns. So it's like a pattern matching kind of thing. It's not as low level or raw as you would do in Common Lisp or even in Clojure. You could do this kind of thing in Clojure and Common Lisp as well, but you have to introduce pattern matching as a thing to make that work, which is fine. You can do that. But the point is, this is out of the box. This was, to my mind, it really surprised me how easy it was to get what I wanted out of that syntax extension. And it worked almost on the first try. I had very few iterations where I was like, oh, what's going on? So you can see here it's interacting with CLR functions within Iron Scheme. But the real power of this is how expressive it is because of the pattern matching. And so I'll talk about that a little more later. Another example of a syntax extension that we created, this one. So Iron Scheme has a link implementation. I don't know if I need to explain what link is, but I'll be real quick and try. It stands for Language Integrated Query. And the idea was to have sort of a SQL-like expression language, which they added to C# and VB in the last 10 years. So that you kind of feel like you're manipulating even generic collections with a kind of SQL-like syntax. So it's something like, from this, select that, order by, et cetera, and so forth. So those concepts are there. So the maintainer of Iron Scheme saw fit to implement the entire link specification as defined for C# in about 900 lines of scheme code. This is amazing. Like, this is why it's so awesome. So he created this concept called an iterator, and it has these three things that are common to all like iterator abstractions. And has nothing to do with C# whatsoever. This is pure scheme. So I couldn't use it when I wanted to use it against .NET collections. So I was like, I need to create a bridge. So it was as simple as writing this little syntax expression, which gives you a couple different ways. You can have a flavor of it with no parameters, or a flavor with both none and one or more, or at least with one starting out is about as much as I've needed to do. I'll show you what that looks like in a minute when you use it. But the idea here was to kind of create a bridge between enumerator and iterator, and enumerator in .NET with the idea of the iterator as Leppy had created it in his link implementation. Et voila! All of a sudden now all the collections in .NET, almost all of which use enumerator at some point, because that's what makes link work on .NET. All of a sudden now the whole world of .NET collections are now available within Scheme. So what does that look like? That's what it looks like. This is a real simple example just to give you a visual. As you can see, it's like you get your kind of for each concept, which is introduced by link, and then you have, you have like from X in select data, join Y in group data on X equals Y into Z, from W in Z, select W, right? That's a very common type expression you'd type in C# or VB with link, and it looks and it feels like SQL. Except it's working against generic data types, and that's kind of a powerful idea. This is how easy it is to use the defined enumerable syntax extension, right? All rows in a delimited text reader from the Sylvan library. Because reader already implements enumerator, I just pass it in as is, and that's it. You're done. Now you can use it. For something a little more complicated like triples in an RDF graph, where in this case I have some concept of interacting in a REPL with one or more data sets. I have this idea of a current graph. So that's what that use case was. So if you give me no parameters, I'm gonna use the current graph, whatever the most recent graph you were touching is. Yeah. Otherwise, if you give me a graph, I'll use that as long as it's a real graph. And if it's empty, I'm going to go make that the current graph and use it. So that logic there is so simple, was so simple to implement with that little handy extension. But I did run into some interesting gotchas. enumerator on .NET's not well behaved. It seems to be the reset contract is more like a suggestion, and almost nobody does that consistently. Sometimes you'll get no behavior, sometimes you'll get the behavior you expect. And this is on a per collection basis, and other times you'll get an error. So I had to kind of work around that. And that would be true even for an equivalent implementation in Clojure, which I am working on. So overall on .NET, and this is also a problem for Clojure, compiling to binary on .NET Core. That's the flavor of .NET that runs on, say, Linux and Mac, independently of Windows. It used to be possible, and then somewhere around version 3 of Core, Microsoft decided to remove saving to hard drive from reflection emit, which is what most language implementers on the platform use to generate IL code. So both Scheme and Clojure had this problem for the longest time of not being able to pre-compile or do what you call AOT on .NET Core. This is just a little ping reminder to myself to talk about how cool David Miller is. He's been working on this problem and found a third-party IL generating solution that he has contributed to fix some issues with it to make it usable in Clojure. So the next soon-to-be released version of ClojureCLR will actually have the ability to compile and pre-compile code to binary on non-Windows platforms. The big thing to lead into kind of why I was looking at Clojure beyond Iron Scheme is that it presently doesn't allow for creating CLR types or implementing interfaces, which is consistent with its purpose. It's really intended to be a scripting language to expose the objects of your application to scripting, which is a common use case for Scheme, like with Guile. We need to do this. We need to be able to create some objects on the fly, even behind the scenes when the user doesn't have to think about them for certain, use cases I have. And so that was one of the motivations for using Clojure, because creating custom CLR types, subclassing existing ones, or implementing interfaces is a breeze because of Clojure's quote unquote interop with the runtime, which is a bit deeper in that regard. The bottom line is Scheme's syntax was the syntax extension facility made it really easy to kind of craft the right entry point for non-programmers so they can learn how to use it first and then kind of get excited about what they could do with it as they get deeper in it. I found the macro hygiene benefit of Scheme to be a little less compelling and something at some point I needed to break out of, which is possible. But the pattern matching concept is really great. So I quite enjoy it for that reason. .NET's kind of a big and complicated beast, and the idea here is with proper Lisp, Clojure and or Scheme, a little bit of creativity and some high touch things that you implement to help your users adapt can really kind of set the bar higher than has been set before for these kinds of solutions. I'm not going to get into the Babashka versus Dadoshka stuff. That's kind of a funny play, because the Babashka is like a play on babushka, which is like grandma, and Dedushka is like what you would call grandpa. So I was kind of playing off Bash and DOS there. But there's no reason why something like Babashka or even something more .NET specific like that couldn't be done on the CLR now. And that's something to think about. In any case, there's plenty of room here for another Lisp on .NET, and that's going to kind of signal my transition to the next part. Why on earth would we add Clojure after having all that great fun with Scheme? And here it really is about interop, and it's interop in a bigger concept. So what we're really trying to do with Office as the entry point is redefine what we mean by legacy app modernization. There's different approaches to that term that are common, like stack driven. We got to be on the latest version because this other version is going to be deprecated, or there's new whiz bangs we want on this version of the stack we're on, or management really wants to have a better dashboard and they found this thing, so we're going to stop using the thing you like and we're going to move to that. And then there's buzzwords, everything has to be web enabled, the investors demand it. Like all those kinds of legacy app modernization usually end with pain and minimal success. I think there is a concept of legacy app modernization that's always justified and worth pursuing, and it has to do with making information in any system inherently shareable. If you had the interop solution of your dreams and you turned it on today, there aren't very many systems that could take advantage of it. And so part of the reason we were looking at entry points to prove this concept is that Office solutions are all over the place. They're in enterprises and small businesses. It's on almost everybody's personal computer, particularly if you buy Windows out of the box. So the reach of it potentially is crazy. I think that we could use the power of these languages to simplify turning these solutions into cloud-savvy linked data microservices. So there's a heavy emphasis in Accelerate on RDF, on consuming data from all kinds of crazy sources, whether it's data, SQL data or CSV or structured, semi-structured. And we, with a little bit of sweat equity, we can take traditional Office and Microsoft weaknesses like lack of interoperability, can now become a great strength, and make them play nice with the rest of the enterprise. And that's a key point. Everywhere I've ever been, you'll talk to a data architect and they'll be like, yeah, but we don't know what we're going to hear from next. Some department has this thing they've been using for years they didn't tell us about. That's a big problem. And I remember at one point at the VA, we were asked like, hey, would you guys have some ideas about this problem for us? We've got all these like homegrown access applications people built because they were tired of waiting for IT to do something. So that happens a lot. And I've seen it everywhere. So it could be a very big thing. The overall goal that we're after is something called data interoperability. And from that point of view, as I kind of alluded to, Office solutions are kind of like low-hanging fruit there. They're typically domain specific. They have kind of a narrow path to upscaling when an organization outgrows them. So you build this solution for your small business, it works, and then you hire 5 people, you have another office. Now what? Because all this stuff just runs on documents on my machine. How do I do that? And so Microsoft says, oh, SQL Server and SharePoint. But really, we're moving to a world where the cloud, people are really starting to grasp the idea of the cloud as, leasing other people's machines. So technically, you could be your own cloud. So we want to be neutral about that. You want to use Azure or knock yourself out. You want to use AWS or Google's cloud. You can, IBM, whatever. But you can also be your own cloud. And I think a lot of small business people aren't so comfortable moving all their stuff into someone else's machinery if they can competently run it from their own with minimum pain in between. So, giving them a path toward achieving that is worthwhile. And that's why I think eventually VBA programmers are going to come around to this notion. But they got to see it first. So that's what I'm working on. Shareable information is the key notion. The concept of interoperability that I'm coming from, that I just want to share, I don't know if anybody not in healthcare probably hasn't heard of this, but the HIMSS organization, which is Health Information Management Systems Society, to which I belong since we first did our work with the VA. They have defined what interoperability is in terms of these 4 levels. It used to be just 3. Recently, they realized there's another dimension to the problem, and I like their approach. It actually, what I'm building, even though it's kind of contrarian to the way they think about interop conventionally, I like to think I'm going to hit all 4 levels with our definition of interop and our implementation. The first level is just, can a computer connect to another one? That's no big deal. Everybody's got level 1. Level 2, you start thinking about the format and the syntax of the data. Everybody that ever did WSDL or RESTful web services has that level, right? So it's kind of a structural level. Then you get into semantic. This is where you don't necessarily need human intervention for the underlying systems to know what to do with the data, to understand kind of, as it were, the meaning of the data, hence the term semantic. This is really where shareable information, and what do I mean by that, comes in. And then the 4th level, which is very important and only recently got added to the HIMSS definition, has to do with governance, policy, social, legal, organizational considerations. There's so many non-technical obstacles to interop that are actually sometimes far more show-stopping than the technical problems. And it's really good that they've sort of formulated that in their official definition, because if you don't deal with those reasons, any technical approach that you have that sort of compels people to work one way is going to fail. And that's been the experience of the industry so far. So what's linked data? Some of you may already know this. It's basically a W3C standard. It's really an information model. It's known as RDF, or Resource Description Framework. It's an information model based on statements of fact, which are composed into triples: the subject, predicate, and object. The subject is anything you're talking about, and the big rule in the early linked data / semantic web was anybody can say anything about anything. So it's got this open world sort of assumption. The predicate is like some property or attribute associated with the subject, and the object. It's a valid value for that property. You'll see a parallel here to datomics concepts, which it was modeled, I believe, pretty clearly after some of the concepts from RDF. Multiple triples form a graph. And again, just because data isn't in this graph doesn't mean it doesn't exist, which is a different assumption than most systems of record or formal databases have. Graphs can be queried in a language called Sparkle, which I call that the original GraphQL, because your information can be shaped any way, and you can specify how you want the data to come back precisely. So I've always liked Sparkle. It's a little bit syntax-wise closer to SQL, but it's far more powerful. Graphs can be linked, meaning you can kind of develop mappings between concepts. And from this point, you can also do inferencing. You can start to conclude new information based on existing information. This is something you can't do in SQL, and you can't do this in GraphQL. So it's a very powerful system for allowing maximum automation of interchange of data, and it does require creating rules and stuff like that. But that's all very well specified by W3C. So it's a good standard to target, and I like it for that reason. What do we need to have data interop? Well, first of all, we have to reframe what legacy app modernization is. I talked about that. We have to come up with a way to operationalize the sharing of data. This means kind of the data that's going all across the wire has to be written in the language of the domain. And again, here too, the semantic tools from RDF give us a way to do that. It's really important to prevent throwing bad data after good. That's kind of like the key concern of any operational data sharing that prevents a lot of data sharing, because people really don't trust each other's data very much when they talk about sharing. They really talk about collaborative curating. And that's really what our solution is built around. So in terms of the phases of interop, you want to prepare your systems of record to take advantage of this world. And that usually means bringing an adapter concept of some kind. So when I talk about linked data microservices for Office artifacts, what I'm really talking about is an adapter pattern. And that's something that we're going to generalize in the next step with Domain Master and Unify. At that point, now you have systems capable of generating change and receiving information about change, and then as appropriate, applying it to their system of record. Any questions so far before I keep rolling through here? Okay, so we can get back to let's get back to why Lisp again. Remind me. Again, Scheme for casual scripting, automation, lambda functions, great alternative to VBA, and JavaScript / TypeScript. And incidentally, that's where Microsoft's moving with their add-ins. They're kind of getting people to try to create Node.js add-ins, and those haven't really proven themselves in performance-wise yet, which is why they haven't taken off. That's where Microsoft's pushing the world. So VBA people, I want to teach them Scheme so they can kind of be masters of their own fate with respect to that. Clojure for portable microservices, and by portable, I also now mean potentially the Java version of Clojure. More advanced data-oriented development work. I'm a big fan of data-oriented programming. Jonathan Charvit, I think his book on data-oriented programming is one of my favorites. It really kind of gets you into the mindset behind where things like persistent data structures and Clojure come from, and why they're pretty awesome. And of course, there's a deeper platform integration with Clojure than pretty much any other scripting language. But both of them run on .NET, which means that as a bonus, we can interact with VBA solutions. There's an interop assembly for talking to Visual Basic environment, so you can actually directly interop with VBA solutions that are out there. And again, I already kind of covered why two of them, so I'm not going to belabor that. I will emphasize a real important point that I'm working my way up to about Clojure, which is that it has an immense reach, right? You're not just talking about .NET or Java, you're also talking about JavaScript. And then there's even Erlang. There's an implementation of Clojure on Erlang. And that's, when you start thinking about that idea of cross-platform APIs, that's one of the first things I'm working on here is this generic adapter platform. It's going to be interoperable whether you're using .NET or Java version. And I'll talk a little bit about how that's possible. I borrowed this one from one of my other slides, probably a bit primitive, but the idea here is the S expressions are based on lambda calculus, and both Scheme and Clojure are lambdas all the way down. Take away a little bit of syntax sugar, and it's all lambdas. So first class functions, very powerful in Excel context and even SQL. The ability to have variadic functions, currying, composition, like these are things you just can't do in VBA or any of these other kind of built-in things for developing solutions in .NET or in Office. You've got these aren't toys either. There's serious concepts. It's R6 RS scheme, so you can create libraries per the R6 RS spec. Which means that it can be an arbitrarily large system you develop in it. It's not trivial. This isn't like just for scripting. You can actually build real systems. With Clojure, you have namespaces, you have the whole JVM. Modular programming on the JVM is something that's well known, and it's been accepted in the enterprise. So you can knock yourself out with these. But by the way, we deliberately don't embed the code for that level of coding in the spreadsheets or in the databases, precisely because we want to be able to reuse code through source control. Whether open source or otherwise, having that kind of source control friendly approach is a big difference to working in VBA, which is a bit of a nightmare. If you've ever tried to build a VBA solution as a developer, and then you've got someone using a copy of that on their desk, and then they send you a problem, it's madness. Here, at least, we have something like Git to bring some sanity. Full CLR interop, full reach and breadth of the platform at your fingertips, both inside and outside of Office. And of course, macros, we talked about that. You have the full reach of Scheme and the full reach of Clojure. This is something I think we talked about in the pre-interview. That's kind of mind-boggling, and they can call into each other's APIs at will because they're both on the CLR. So the realm of the possible here is kind of crazy to contemplate. The big thing in Clojure that makes this trivial, this portability that I was talking about earlier, is what do you call them? Reader macros, reader conditionals. Here I was just like showing you, and for the .NET and the Java version, these reader conditionals make it possible to kind of what separate out code that's specific to the platform. And this is something I'm adopting very heavily in our development in .NET, precisely so that we can pull in existing libraries or create new libraries on the JVM side that are kind of the same. The difference between Clojure style macros and syntax extensions, I'll just briefly kind of go over a couple of things that occurred to me as I've been working on these. Clojure macros are lower level. You can shoot your eye out if you try hard enough, but anything is possible. If you can imagine it, you can do it. This style heavily favors Lisp idioms, which is a good thing. A little bit less necessary in everyday Clojure coding because Clojure has a lot more going on as a language. And there are already existing macros that handle so many cases that you could think of, and I'll show one if I have time a little later. Syntaxes in Scheme are powered by this pattern matching kind of DSL that's built into the language, and they operate at a slightly higher level of abstraction with the code, which makes it extremely simple to craft DSLs. You can really go nuts with them. This is why you have, like, if you go to the Racket website, they talk about language-oriented programming. That's like a major killer feature of Scheme that's quite cool. Their emphasis on hygiene is good for people new to Lisp that are going to be prone to name things similarly or whatever. I really didn't find that quite as useful. And I found at least one occasion where I wanted to break out of that. But you can, so it's adequate. But if you really want kind of full power, you're going to use something more like Clojure or Common Lisp's concept of macros. It really doesn't matter which one you use. It's kind of a matter of preference, the needs of the domain, your users, your own preference and experience. I find them both great. So I'm kind of a both and kind of guy. And there'll be times where I'll look at a problem and say, this is a better fit for, a Scheme extension. I can probably get it done faster and prove the concept. Or I'll say, you know what, I could do a toy thing in Scheme, but I really can make that rock in Clojure. So it just depends on the use case and your own kind of tolerance for going down which rabbit hole. This concept of database transparency I mentioned earlier, this is something I'm trying to bring into the Office suite. It's kind of one of the big influences on me very early on when I first got into programming was a database language called FoxPro, which was based on DBase back in the day. And I just love that system. The SQL was kind of like right built into the language. And the language was, far more object oriented than anything in the VBA world. Back when I still thought that was the best thing. Live and learn. But I definitely really have been influenced by that. And so I'm trying to bring that sort of concept of database transparency back into the Office space. It's a sub goal. It's not my primary goal, but I think it can help achieve the bigger goal, because now we're going to take these data silos and put them on an information model that opens the door to the kind of interop I want long term. Quick example of what that looks like in Scheme. So obviously I talked about link. You can see here the idea is that I could not only can I do it with generic collections, I can actually do it with database results. And the more interesting point that I'm really trying to make with this example is that you don't have to even do this in Clojure. In Clojure, all you've got to do is extend the 8.0.NET data result types with seekable, make it seekable. And that's, also a tiny amount of code using the existing macros for that, whether it's extend protocol or you want to, do more concrete thing. But Clojure, not only is it transparent, you don't even see the database anymore. You're just dealing with the same data you deal with everywhere else. And I think that's a really great plus, particularly in the data interoperability world. It's taken you a step away from the implementation specifics, and you just got the data. And now when that stuff kind of goes over the wire, the other properties of Clojure, the fault tolerance for, hey, I don't know what that is, but I'm not going to blow up. I'm just going to ignore it. Like that whole idea is quite powerful for building systems that don't, fall apart, that aren't brittle in the face of the unknown that might be coming over the wire. So if you want to, I ask myself, like, what does an interoperable enterprise app look like? What could that look like with Clojure? I can tell you that I'm building Accelerate DB, Forever DB, Domain Master, all of these on this basis, because I do want to have that reach and be portable into, the full spectrum of places that Clojure can be a factor. Here I just simplify it by showing CLR and JVM, but your application sits on top of Clojure core. Both the CLR and the JVM have the same Clojure core, and they behave the same way 99.99% of the time. There's always a little bit of nuance per platform, and some gotchas, and that could be a whole talk someday. But the idea is you're now going to take some of these platform specific solutions that are out there and begin to kind of pair them up with what you're trying to do. So for example, if I want to use SQL and I want to use RDF kind of in the same solution, right, it makes sense to have Apache Jenna if you're on the JVM. If you want to talk to Office documents like Excel documents, particularly, that's pretty popular use of it. You got Apache POI. So you can take the open XML formats of these documents and use them to get data out of them in your solution. And then there's a zillion different SQLite Java wrappers. On the CLR, you would turn to .NET RDF. You look at maybe Dev Express Office API. All of that, by the way, is out of the box with Accelerate and Microsoft SQLite for the ease of creating these custom functions in particular. But the point is, you got choices, and you put those choices down here. They don't affect your application's API. If you've done the job right, you can have a top-level Clojure API for developers that isn't different based on what runtime you're running on. And that's sort of the ideal toward which I'm moving in my own work with these adapters, the adapter platform. All right, so some upcoming commercial products and open source projects. I'm just not going to dwell on this. I'll just kind of go over these at a high level, and then we'll take some questions. Open source, we're working on something called CLJR, which is a depth CLI for the CLR. I'm already working on this, and I've got bits of it already kind of working. So the depth Eden files have the benefit of being just Eden, which means it's just data. if I were to tinker inside some of the keys like deps or aliases and try to throw in something like NuGet instead of Maven, things go blow up because those are well defined per the spec. So all I've done is I've added CLR deps and CLR aliases. So the same deps file can serve both .NET and Clojure. But within those keys for the CLR, everything specific to the CLR is there. So we're integrating with things like NuGet for dealing with the fact that unlike Java, unlike the JVM, the CLR has different versions of itself. So you've got the Clojure, you got CLR Core, you've got the .NET framework, which runs only on Windows, right? You've even got Mono, which is kind of like the .NET normal one, but it can run on non-Windows. So all those are factors that don't factor into what you need to do in the JVM side. So that's all there and going to be present in our flavor of dep CLI. But the point is, you could take an existing function, an existing project that's already done on the JVM, and very easily just add what you need for the CLR side of things. That makes supporting existing CLJ libraries to the CLJR is going to be, I think, pretty straightforward when we're all done. And we'll be releasing that over the next couple of months as we kick off our other efforts. Be able to, I'll send you out an announcement when that happens. If there's an interest in just looking at something like that for a talk, I wouldn't mind. The commercial side, we got Accelerate Pro coming out shortly. And that's where we're really bringing in linked data microservice adapters for Office data silos, and then Domain Master, which is the much bigger vision of Interop that I didn't really get into today about how that would work. That's where we use things like blockchain and some of the other things that are more about the propagation of change. So I think that's most of the content I have for today. If there's any questions, I'm happy to take some.